So welcome to this week's lesson on maps. We will be going through two notebooks today. So first, a notebook on creating static maps. We will be using matplotlib that we have been using before as well, but using matplotlib and Geopandas to create maps and different kind of visualizations in the first part of the lesson. And then in the second part, we will be creating some interactive maps with a package called Folium that works together with a JavaScript library called Leaflet, so that we can create interactive web maps that can be posted online, which you also will get the opportunity to do in this week's exercise. All right. And as always, if you have any questions or if I'm going too fast or too slow, let me know in the chat. But if there are no comments at this point, then I'll jump into my CSE notebooks Jupyter Lab instance and go into AutoGIS and notebooks and lesson 5 and open the static maps notebook. And I can zoom in a little bit. So here we are going to be creating different static maps. And for that, we will be needing some data. The data should be located in the folder at CSE already. In case it is not, or if you're working on your own computer and don't have the data, then there are instructions here at the top for how you can get that, but it should all be loaded. So hopefully it is. So yes, we will start to create some static maps by using Geopandas and matplotlib. You've already been slightly introduced to this before, but we will continue to build upon that. So first of all, what we're going to do is, as always, we will be importing some modules. Here we are starting with Geopandas and the CRS from Piperoy and matplotlib, so familiar packages. And then we will be needing some data. So here the data file paths are already typed out, and then we will be reading them in with Geopandas. So just to start off, we will read in the different files by running the cell. And then as always, when we are plotting, making maps or doing spatial analysis, we need to check the coordinate reference systems that we are using. So to do that, just a repetition, as we have done this before as well. We will be printing out the CRS information about the different files that we have loaded into the geodata frames. So we will start from the top with the grid layer, accessing its coordinate reference system information by the .crs. We can see we have it in a 3067 CRS, which is familiar, and I can copy and paste and edit it for the roads CRS, and then do that the same for the metro CRS that we have loaded. So yes, forgot to introduce the actual data that we're using. The grid data is the travel time matrix that you are familiar with from previous lessons and exercises. And then we have some road, a shapefile with some roads in Helsinki. And then we have a bit old shapefile of the metro line in Helsinki before it was extended. So we will see how that looks later. But yeah, so we have the grid layer that we know from before, and where the CRS is the EPSG 3067. And then let's also print out the CRS of the last two layers that we have. And as we can see, they are in a EPSG 2392, which is something that we haven't seen before in this course. But that is an old CRS for Finland. Finland used to be split up in 3 different regions. This is one of them. So it's not really that much used anymore, but there's still a lot of data out there that is used in this type of or in this coordinate reference system. So it's a nice exercise to just know how to handle that. Yeah, so another way we can get some more information about each of the CRS is to access their names. So we can do that by printing. If we start with the grid, we can print the CRS. I think we can print the name. Yes, we see we get the full name of the grid, and we can do the same thing for our road CRS and get the full name of the roads CRS. So yes, it's the KKJ Finland Zone 2 CRS. And as we have covered also in the CRS lesson in the course, we want to reproject one of the or reproject our geometries so that they are all in the same CRS or coordinate reference system before either plotting or doing operations. And as we also talked about previously, then it is a good idea to take the more complex CR or geometries, the layer with the more complex geometries, and use that CRS as the base CRS and convert and reproject the other layers into that geometry or that CRS. So we will do that now. And so for us, the grid CRS is both in this case the CRS that is more common and more up to date. So that is also a good indicator of which CRS to use. And also the geometries are many different grid cells. So while the road and metro are not that large data sets, so it's easier to reproject the roads and metro into the grid CRS. So let's do that on the fly. We have done this before, so I'll do that a bit quickly. So let's replace the roads geodata frame with a reprojected version. So it has already a CRS, so then we can convert all the values from one CRS to another, and let's then use the grid CRS as the CRS we are projecting into. And then we can do the same thing for the metro as well. Metro and metro. All right, so when we run this, it should convert the layers into the grid CRS. And we can also double check that by typing roads CRS and seeing that it's the same as the grid CRS, for example. And one can even check that that is also the same as the metro.CRS and see that we get true. So the road CRS equals the grid CRS, which is the same as the metro CRS. All right, so far so good. Then we have our data and we can start exploring it, visualizing it, making some initial plots. And that's where this check your understanding comes in. We will take 5 to 10 minutes, depending on the green check marks. But you will now try to visualize the data that we have. Start with plotting the grid layer and using the quantiles classification scheme, and then also add the roads layer and the metro layer in the same plot. Yeah, so 5 to 10 minutes where you do that in the cell below. There are some color map hints that can be useful, and yeah, some coloring options for you. And you can of course also use the course webpage, but I challenge you to do this just initially from the top of your head. How would you go ahead and do that? What I would do if I were tasked with plotting different layers, the simplest way to start is to just start to plot and see how the different layers build upon each other. So you could start with our grid layer. Let me see, what's it called? Grid. Yeah. So grid and then plot, and just running that is the first simple step to see how the data looks like, and how we can start building upon that. So the first task was to plot the grid with the quantiles classification scheme. So as you might remember, to do that, we need to define which column to classify and what to use for the visualization. So we can define that by giving a column, and I think in the lecture materials we use the car travel time, car rush hour travel time. We can try to plot that to see how that goes, and then we can see already that here the classification scheme that we're using, or the column that we're using, already gives us some information about the grid layer and the data underneath. So with the travel time matrix, we know that this is travel time in minutes from one specific grid cell. And as we read in our file here, it was from or to the railway station in Helsinki. So we can see it matches up pretty nicely with what we might expect from that. But we can also further improve our grid plot with giving first a color map. We can choose a different one than the one from standard. So with the C map parameter, we can pass it for example, a spectral color map, which results in a map like this. We can also see some red spots where there is missing data that we haven't fixed, that we initially, or in a perfect world, should have fixed before starting plotting, but we'll leave that to later. But yes, we wanted to use the classification scheme as well. So that is the scheme parameter, and we set quantiles. And as you might know, or maybe have read in the documentation, then quantiles will try to divide our data based on the column we pass it into 5 classes initially, but we can also give it a some breakpoints, a number of breakpoints we want to have, like we've done before with the K parameter. So here we have 9 and get a lot more different colors in our data. Yes, and there is also an optional parameter called alpha that we will be using a bit more later as well, where you can set some transparency on the layer that you are plotting. So that ranges from 0 to 1. Let's just do 0.3 to illustrate the difference. So here we have a very quite transparent grid layer, or we can set to 0.8 to get a bit more clear image. So if we say we're okay, happy with the first grid plot, then the next task was to plot the other 2 layers on top of our grid layer. So we have done that before as well. So what we first could do is just check out if we wanted to plot the roads layer, what would happen then. And what happens is that it plots it on a separate subplot, but we can also see it has it's in the same coordinate reference system and in the same area. So we should be able to plot it on top of each other. And then a good way to do that is to assign which active subplot that each layer is plotted to. And one very handy way to do that is to first create a subplot and then assign the different layers to each subplot that we want to use. In this case, just one subplot because we want all the layers on top of each other. So we can do that by first creating a figure and an axis with the matplotlib function subplots. And here we can also specify a size of our figure if we want to do that. So if we give it the fig size equals, and that is a tuple, so we can give it 1410, and then the different layers that we're plotting will then be plotted on a AX parameter, and here this is then the AX refers to the AX in our axis in our subplots. So if you do that both for the grid and for the roads, pass them that and run the cell, then first of all we got a much larger figure, and we can see that our roads are plotted on top of the grid cells. So that is good, and then we can even give it a different color, make the roads gray, and change the line width, for example. Whoops, to just 1 maybe, and plot that. So now the roads are also there, and we can do the same thing for, if we just copy that and paste and change to metro, then we can change to a red and a bigger line, plot that, and that will produce the old metro line on top of our map. So that is basically how, or one way to plot on top of different layers on top of each other, as long as they're in the same CRS. And then it's also a good idea to save the figure to a file, and we can do that by defining an output file path, call that a static map.png, for instance, and then use the matplotlib plt savefig function, pass it the file path, and then there is also a optional DPI, so the dots per inch parameter. Setting that to 300 should produce a quite good and large file. So in the file browser to the left, we got a file for the static map, which is very large. But here is the map that we just created that can be downloaded and used in a report or a thesis or in an exercise or something like that. All right. So another common thing that we might want to do when creating maps is to create a legend to our map. And that is possible in quite easy, both quite easy, but it can also be quite cumbersome depending on how much you want to edit the legend yourself. But let's give it a try here. I will copy our grid layer and our figure creation on top here, just to get us kickstarted. So if we just plot that to begin with, we see what we have. We have our big grid plot. And we can, if we want to add a legend to our figure, there is a parameter called legend. If I can type it correctly, and that can be set to true. And if we run that, then a legend is created for us. So here, since we have our scheme, classification scheme set to quantiles and the breakpoints, we get each of the different classes in our data. And as we can see here, it ranges from, so -1 is the no data values, and up to 79 minutes in travel to the railway station. So that is one way. If we have a classification scheme in our data, then that is possible to have it in this way. But we can also, let's copy again and try to remove the classification scheme settings. So again, this is our grid layer with the column car time travel in rush hour with a color map, and then we want a legend. If we don't have a classification scheme, it will produce this kind of color bar. So that ranges from the minimum value in our data, that is -1, and our maximum values that are just below 80. So that is like the standard way that the Matplotlib provides a legend for us if we don't have a classification scheme. So one way we can change that is to provide some legend keywords if we want to provide some more information about what is it this color bar actually represents. So we know it represents travel time in minutes, but that is a nice thing to also present in the map. So what we can do is, let me split up this parameters on new lines after the comma, and I'll show you why in a minute. But here we can provide the legend underscore KWDS for keywords. And we can then pass it a dictionary of parameters that we want to pass. So we could pass it a label and set that to travel time in minutes, for example. And if we run that, we should see that here we now have a label to our color bar that is assigned through our legend keywords. And there are many different keywords that you can access and edit for in Geopandas, but this is just one of the keywords you can pass it to easily improve the legend. And yeah, the reason why I wanted to split up all the different parameters here is that if it were all on one line, then it's difficult to take out one piece of where I would have to delete a bit of the code in order to not run it. But when in kind of this testing phase, you could, when they're split up in different lines, you can comment out one in one line and then still keep all the code there without having to delete it. So I seem to have some connection issues with Jupyter Lab and CSC, but it seems to be working again. All right. So that is one way to access the legend and plot and change the information there. And I can see that from the lesson materials that I was a bit too quick for myself for the classification scheme legend. So let me just jump back there to that as well, because there are more things that we can do to improve this legend as well. We can also add a label, like we added the travel time minutes for here to the label. Let me just copy that. We can add that to this label legend here as well. But the Matplotlib provides the access to the label in different ways, and it might be a bit difficult to kind of intuitively understand why. But what I want you to kind of get out of this example is that when plotting in this way with a classification scheme with different classes, you get this type of legend. And what you can do with that is you can access it as part of the axis from Matplotlib. So the AX that you remember from here, the axis that we plotted to, we can get the legend from that axis by using the get legend function. And we can then, for example, set the title to, and I'll paste in the travel time minutes here. If we run that, we can see we have a new title in the legend here as well. And we can even move it around if it, in this case, our figure is quite large, so it doesn't block anything, but you might run into, if I just make the figure a bit smaller, you might run into issues where, like here, the legend is on top of the actual data that you want to visualize. And in those cases, you can move the legend as well. And that is also in the same format. So you'll get legend and then set the bounding box, so B box to anchor. Let me anchor is what that is called. And that also takes a tuple that will set the bounding box of the legend to this specific point. So this might be a bit fidgety to get it to work, and you might maybe need to do some trial and error. So like in this instance, that wasn't the most pretty thing, so can move it around. That is again too much. 1.35. So there we go. That is an example of how you can access the legend and then edit each of those elements. And there are a bunch of, if you look into the documentation of the Matplotlib legend, there are a ton of options for what you can do and how you can edit it. You don't need to know all that. That's perfectly fine. I just wanted to, so that you know that there are a bunch of options that you can do if you want to edit the legend, for example. And at least if you are doing a lot of plots and a lot of maps, it's nice to be able to do that in Python. If you're just making one plot in Python, then you could, for example, take it, save the file, edit it in another software, Inkscape or Photoshop or whatever. But if you're doing a lot of maps, then it's nice to be able to automate the whole process, or as much as possible. All right. I hope that was somewhat understandable. Please let me know in the chat if there is anything I need to reiterate or you didn't understand. But if not, we will continue with adding a base map to our data or to our plot. And that is something that is often done. One of the main challenges of adding base maps is that base maps are usually in the Mercator or Web Mercator projection. And as base maps are basically just a bunch of tiles of images that are referenced geographically, they are not that easy to kind of reproject. That will often result in a weird looking map or base map. So what is often the better option, especially visually, is to reproject the other data into the Web Mercator projection. And that is the EPSG 3857 projection. So we will try to do that now. There are a bunch of different providers online for different background maps. So both OpenStreetMap and others provide these base maps that you can get into your own maps. So we will be doing a few examples of those now. To start with, we will read in the packages that we need and our data files. So as you can see here, we are importing a package called Contextly, which which we use to access these base maps and add them to our plots. So let's first read in our data. Let's use the grid file again, and let's check the CRS. So we'll print the grid.crs. We can see that it is in 3067. But we need, but that is not Web Mercator, so we need Web Mercator or reproject our grid data to WebMercator. So let's do that and store that in a new geodata frame called data. Let's do that on the fly. We take the grid data and use the toCRS function, and we can use the EPSG equals 3857, which we know that is WebMercator. All right, so we can also here now take a look at the data.head to inspect our geometries and see that they differ from the geometries in our original grid data. We can see they have been reprojected. So far, so good. So what we will do now is to plot the grid, the new or the reprojected grid layer, and then add a base map afterwards. So we start by, again, creating a figure and the axis object from matplotlib using the subplots. Let's do a fixed size as well. So there, if we run that, we see we get an empty plot. So let's take our data layer and plot it to the axis from our plot. Let's then select a column. We will take the public transport, rush hour, travel time, and use a color map. We can go for the red, yellow, blue. Let's try to plot that to see. Yes, and we should also use a quantity classification scheme. So let's go for scheme and quantiles and use the 9 breakpoints. So here, similar to what we have seen before, this is our grid layer plotted. And what we can do is then to try to add a base map on top of or behind that. So that in order to do that, we use the contextually package, which we up here imported contextually as CTX. So contextually has a function called add basemap. So we take that and pass it the active plot or the axis that we want to plot the basemap onto. So in this case, the AX object. If we run that cell, then we should get a plot of our data, and behind that a base map. And since this base maps we are calling the contextually service and getting the base map, it might take some time, but here it is ready. And so here we can see the areas around our plotted data layer. So if we wanted to, in a way, make more sense of also the underlying base map, then we can set a transparency to our grid layer. So if we take 0.5 and run that again, then we should also be able to see some of the underlying base map here. So we can especially, or for instance, see the roads leading in, the main roads leading into Helsinki. Okay, so that was basically a simple way to add a base map to a plot. What we can do is if we want to change out the base map, there are a different set of providers for for these map tiles. As we can see from the plot we have made, these map tiles are by Stamen Design, and the map data is from OpenStreetMap contributors. So that is free to use, but there are also in the Contextually package, there are different other tile providers. We can check those out by using the dir function and checking out the directory of our Contextually providers. So if we run that, we can see a bunch of different providers of map tiles, from OpenStreetMap to Mapbox and CartoDB and S3. So yes, there are different ones you can choose from, and even from the Contextually providers, you can also access the other subsettings of the different providers. So if we take, for example, OpenStreetMap, and access the keys of that, there are different styles of maps that OpenStreetMap provides, which are these with these names. So yeah, we can try to change the base map to one of these. So if we go up here and copy this in order to save some time, then we can paste it here. So we're still making a plot, plotting our grid layer, and then adding a base map to the same subplot. But then we can also pass some parameters to the add base map function. For instance, we can pass it the source parameter, and then pass it the Contextually providers, and then OpenStreetMap again. And then we saw from our dictionary of different styles, we can choose one. We can, for instance, choose the first one called MapNick. And if we try to plot that, it will then use the MapNick style that is provided by OpenStreetMap. So yes, you can see if we scroll up again, the change is not that big, but these styles are quite similar, but it has accessed a different type of or different style from our data. Okay, so what we can also do is to try to subset some of the data in our grid layer to better see some of the attributes of our background map and some of the characteristics of it. So again, I will copy the settings from here and paste them in. But what we want to do now is to try to take a subset of the data to not show all of the grid, but we will here, we will create a subset that takes the data, and maybe let's use the location to locate only the data or only the grid cells that are within 15 minutes of transport, public transport times to the railway station. So to do that, we take from the data in the public transport rush hour travel time cell column times from 0 to or equal to or above 0, and is also data in the same column that is less than or equals to 50. So we take that range of 15 minutes. Save that to subset or to a variable called subset. And if we then plot the subset instead of the data, we first get a warning that we have too many classes, that there aren't that many classes in our data, but that's okay for now. We can try to reduce it to 5 though, or to 4 if it keeps complaining. All right, so subset it to, and then classified into 4 different classes. So now here we can see our data set has zoomed in quite a lot. And it's more apparent the background base map and the characteristics of that. So as you see, it has zoomed in quite a bit, but what we could also do if we want to manually define the zoom level, we can pass a zoom parameter to the add basemap function and then pass it a number. So if we try the zoom level 11, you will see it zooms in a bit too much in a way, but it zooms into the whole of our data set. And we can try a different zoom setting. If it zooms into 8, then it doesn't make any sense. But zooming into 12, for example, defines which zoom level of our base map is being used in the plot. And so that also depends on, or the visual effect of that also depends on at what scale our initial data set is. All right, so let me copy this code, and then here is the zoom level again. So I will skip that cell because that is for the same thing. But what we could also do in order to adjust our static map with the base map is to adjust the axis, the x-axis and the y-axis, and the limits of how long wide and how long the x the width of our plot will be of our data. So if I start by pasting here, we can also edit the credits. So just read that into our data or into our memory. So what we can do is let's go back to our data layer, as that is larger. So by plotting our data, we can again use more classifications breakpoints. But what we can do is by using the ax.set x limits and y limits, we can change the size of our plot. So now let's start by plotting this to see what we have in for initial. So we're back to this plot. And we can also see that our attributions is the OpenStreetMap contributor, but we have, in fact, we have a data layer here that has also been contributed by someone, and that is good practice to attribute that to someone or to the ones who have created it. So here we have a travel time data by the Digital Geography Lab and map data by the OpenStreetMap contributors. So one way to add that directly to our map is in the add basemap function. We can provide the attribution parameter and pass that a string, and we have stored our string in the credits variable. So we can start by adding that here, and that updates our attribution. So that's a good first step. And then to kind of subset, or to just take a bit of our total plot here, we can also then use the X and Y limits to crop the whole figure. So let's do that now. And that is by taking the AX and using the set xlim function. And so within the function, we will then pass it the max value or the min value, and then the max value for the x-axis. So in this case, I will be cheating a bit with the lesson materials. So these are the, you can set these to, in a way, to whatever you want within the limits of the data that we have. But by setting these minimum and maximum values and then running that to plot, we should get a cropped version of our plot, which we indeed have here, a more zoomed in version to the Helsinki city center. All right, so that is the easy way to kind of crop our plot when we have a base map, but that the set X limits and Y limits works even without a base map as well. Okay. So what I will do next is go into our lesson materials on the course web pages and just scroll down to the last code cells that are here. There are instructions on how to use specific base maps from different tile services and different providers, and even it's possible to create your own style of tiles if you're interested in that. But here are instructions in case you would want to do that. So here's an example with using a base map from Carto and using raster tiles, and also by using a darker base map. So we will be doing more base maps as well in the interactive materials that we will do next. But as you might hear, my voice needs a break and some water. So we will take a 10-minute break